Hello, this is the phase shifter algorithm on the disting mk4. The purpose of this algorithm is to generate two outputs with a fixed phase relationship, which we're visualizing here on the Mordax data. So my input signal is a sine wave from the disting EX here. Nice simple sine wave so we can visualize its phase more easily, and the phase shift is set on the Y input and also from one of the parameters, so you can do it manually. The two outputs A and B are here. A can be fixed, or the phase of it can move, and B is the phase of it moves depending on the parameters. So let's start actually doing stuff. So parameter 1 is Y offset, which lets us manually set the phase that we would otherwise set with a CV. So at the moment, you can probably only see one sine wave there because they're in phase. If I move the parameter, I can change the phase of output B is the yellow signal in this case. If I set it to 8, then they're an exact quadrature, 90 degrees out of phase. And just to prove that's not just a delay, that is the same phase offset, whatever the frequency, which is what makes this special. So put that back to 0 and use the CV instead. I've got an LFO algorithm on the disting here, so I'll just set the offset. So that's exactly the same thing as I just did, but by changing the CV input, or actually use an LFO input, and then this LFO is sending the phase, changing the phase of that signal there, which is all well and good. So the other parameters are an internal LFO. So let me just turn that one off. So basically this is doing nothing now. If you enable the internal LFO with parameter 2, then you'll see the phase of the output B continuously moves, and then parameter 3 is the speed that does that. Now, the thing you need possibly to make that more interesting is to mix some of the phase signal with the original signal, which just happens on Z. So Z is a crossfader mixer control, like a number of the effects on the disting. Negative values is a crossfade between the phase signal and the original signal. Center is the unaffected signal, and then positive values mix the phase with a constant amount of the original signal. So if you only want the phase shifter results, turn this all the way negative. If you crossfade, and then you go to the sum. Now the sum is where it gets interesting, of course, in terms of phase relationships and cancellations and stuff. So if we go for a slightly more interesting sound, or for example just a sawtooth wave, then you can hear the phase relationships. And in fact, if we turn the LFO off just for a moment, the one parameter we've not discussed is parameter 0, which is the output mode. So like I say, so far we've been keeping this output fixed and phasing this one. If we set the output mode to 1, then when we change the phase, then B goes one way and A goes the opposite way, which just gives us a different sound. And I should say, if you're not listening to this on headphones or loudspeakers, you really need to, because this is the kind of almost binaural kind of effects you get from this just aren't going to come through or be very meaningful if you're just listening through a phone or something. So if we actually do that, then you can possibly hear something going on there. And maybe we'll put this on a slightly more realistic sound. I've got some stuff going here on the general CV. Let's turn that one off. So now we've got output mode 1, so the two outputs are going in opposite directions. And then we'll turn the internal LFO back on. So that's basically the unaffected signal. And then we'll have some of the phase shifted signal. So that's just phase shifted, or the sum of the two. So it's a relatively subtle effect in terms of the tonal changes, but in terms of kind of fake stereo motion and interesting stuff going on in your ears, it's kind of interesting. So anyway, the phase shifter algorithm on the disting mk4.